Dalton's law of partial pressures. Dalton's law of partial pressures states that the partial pressure of a gas in a mixture is simply the fraction of the total pressure which that gas exerts. Taking a look at the chart below, as you can see here, each component of our gas mixture of air has a percentage, and that percentage is equated to its partial pressure, made up by the total amount of pressure that the gas exerts. When given pressures, the total pressure is equal to the sum of all the partial pressures. Take a look at this example. Calculate the total pressure of gas in a container that has 15 torr of carbon dioxide, 5 torr of carbon monoxide, 586 torr of nitrogen, 3 torr of argon, and 300 torr of oxygen. When we calculate the total pressure, all we do is we sum up all the partial pressures in the mixture. And when we do that, we get 909 torr. Take a look at the second example. It says calculate the partial pressure of oxygen gas in a container that has 15 torr carbon dioxide, 5 torr carbon monoxide, 586 torr of nitrogen, 3 torr of argon, with a total pressure of the container that is 876 torr. Well, again, you're going to use the same formula where you take the total pressure, which is equated to the sum of all the partial pressures. In this case, we have the total pressure, but we do not have the partial pressure of oxygen, so we're going to take that and we're going to solve for it. And we get 267 torr, which is the partial pressure made up of just oxygen. How about what happens when we're not given pressure? Well, the first thing you need to do is you need to make sure you have moles of each gas. The second thing you need to make sure is you have a total volume. If you do not have a total volume, you solve for it using PV equals nRT. To solve for each partial pressure, plug in each mole for each gas in the mixture and solve for P for that gas using PV equals nRT, and do this for each gas in the mixture. To find the total pressure, then you just simply add up all the partial pressures. So, in mathematical terms, make sure you have the total amount of moles in order to figure out the total pressure within a gas. NA represents the moles of gas A, NB represents the mole of gas B. To figure out the total pressure, we need to sum up the total amount of moles within the mixture. And we need R and T, and we divide that by V to get the P total. In order to get the total pressure in a mixture, if we're not given N total, then we simply add up the partial pressures of each gas, which is simply the moles of gas A times R times T divided by V, plus the moles of B times R times T divided by V, so on and so forth, until we get P total. Here's an example problem. It says calculate the total pressure of 10 liters of a 10-liter container with 2 moles of methane, 0.3 moles of hydrogen, and 0.4 moles of nitrogen at 298 Kelvin. Well, first thing we need to do, in order to get the total pressure, we need to get the total amount of moles. So when we add those up, we get 0.9 moles. In order to get the total pressure now, since we have pressure, or since we have the total amount of moles, we have the total temperature and the total volume, we simply plug those in and solve for P. And when we do that, we get 2.20 atmospheres. Using the same problem, it asks for calculating the partial pressures in atmosphere of each gas. Same idea, okay? Except this time you're not going to get the total amount of moles, you're going to plug in the mole value for each gas to solve for the partial pressure of each gas. And here's the setup. Notice how everything's the same except for the amount of moles in each gas. Okay? And when we solve, we get these as our value. Now, these all, just to check our answer, we just figured out in the previous problem that we should get a total pressure of 2.20 atmospheres. Well, according to Dalton, that the sum of all the partial pressures should equal the total pressure. So if we add up all these partial pressures, we should get 2.2. In this case, we do.